Good evening. Welcome to video number 2 of the unit about how the Earth's surface has changed. So here are some additional learning targets that we've added on from the first video. So take a moment to pause it and record those, please. Okay, so we've talked a little bit about weathering. So let's talk about some things that can affect the rate of weathering. Remember, rate is the speed, or how often it occurs, or how much occurs. So there's several factors that can affect this. One of them is climate, and if there's two different things I want you to know about this. Climates that are warm and have a lot of precipitation can have really high rates of chemical weathering, and cool climates that are dry have really high rates of mechanical weathering, mostly due to repeated freeze-thaw cycles. Remember, we talked about frost wedging or ice wedging, and how that can get in, water can get into cracks and freeze and expand and crack it open and break apart the rock. The second factor that will affect weathering is the type of rocks that are exposed. Sedimentary rocks are usually softer than metamorphic and igneous rocks, and they're weathered more easily. Another factor that can affect weathering is the amount of surface area available. In the diagram, you see a certain volume of a piece of rock that's first divided into 8 equal pieces, and then it looks like about 96 equal pieces. No, 64. So as you divide it into smaller pieces, more surface becomes available. The total volume hasn't increased, but the total surface area has. That gives chemicals like acid rain, like that carbonic acid, more places to work. So it has the ability to increase the amount of chemical weathering as the pieces break up. Another example, another factor that will affect weathering, the rate of weathering, is topography. Now, topography is a big fancy name for the lay of the land. Where are there hills and valleys? Okay, it's an elevation thing. And it turns out that areas that have steep topography typically have higher rates of weathering because of gravity pulling water and rocks downhill in a faster rate. So the second step in producing sedimentary rock is erosion. So once the pieces have been weathered and broken apart, now they have to be transported from one place to another. And if you remember, usually the same thing that causes the weathering actually causes the erosion. So in erosion, so I've given you the definition of erosion again, and then gravity's effect on erosion is really tremendous. Glaciers moving down a slippery slope, landslides, mudslides, fast-moving streams or rivers, all caused by the steepness or by erosion. Erosion by running water is probably the most powerful kind of erosion on the face of the earth. It's in everywhere. It's just there's different kinds of running water. Large bodies of fast-moving water causes the greatest erosion, but I think that's common sense. The more water you have, the faster it moves, the more material that it can move with it. Moving water also carries material greater distances than any other erosional agents. Glaciers don't move them that far. Wind doesn't blow sand and stuff as far as moving water can move things. Two things I want to point out. Two words: rill erosion, R-I-L-L, and gully erosion. So we see a lot of rill or rille erosion in eastern Kentucky, especially after hard rains. All the little small streams on the hillside start running, and they start running down the hills and make these little temporary waterfalls. If you have lots of shallow, rapidly moving water coming down a slope, that's the rill erosion. And then if those little grooves and channels become too deep, then it's characterized as gully erosion, deeper, wider ditches caused by moving water. Deposition of materials. Deposition is when the materials stop being transported and fall to the bottom of the river or the lake or the ocean, or if it's a case of if it's wind doing the transporting, the sand might fall to the ground. One really spectacular place to see this is at the mouths of very large rivers like the Mississippi or the Nile. At the end of those rivers, the water's moving so slow that none of the sediments can stay moving in the water, and they're all deposited, and they spread out over very large triangular shaped sometimes areas, and that's where the word delta comes in. So the Mississippi River Delta in southern Louisiana, as it enters into the Gulf of Mexico, has grown tremendously in the last few thousand years. As more erosion has taken place upstream in the Mississippi River, all these deposits have been laid down at the mouth in the delta, and the delta undergoes great changes. And it's something that the government and government agencies track and monitor a lot, especially from space. The picture you're looking at here is taken from space. We talked a little bit about glaciers the other day, and glaciers are these gigantic ice flows that creep slightly downhill. They move very slowly, but they're very, very powerful. Here's a overlook that's actually set up to where you can actually see this glacier moving. Now, glaciers only cover about 10% of the Earth's surface, so it's not a big deal erosion, but when it does occur, it occurs in a very dramatic form because of its huge, massive size. 20,000 years ago, when the last ice age receded, the receding glaciers scraped out or carved out the 5 Great Lakes in the northern part of the country, Lake Michigan, Lake Huron, Ontario, Erie, and Superior. And as these glaciers melted, the meltwater ran in and filled in those scraped out basins, and those became the Great Lakes. And finally, there's wind erosion. So wind is very strong in places that are flat. So here's a nice picture of the Midwest, the Plain States. This could be Iowa, Nebraska. And if there's little vegetation, little plant growth, then wind erosion can be quite devastating to land, to soil. It can blow it all away. So even with farms that have vegetation, crops, corn, and soybeans planted, the blowing wind can still cause damage. It can still cause soil to blow away. So farmers plant trees, because trees aren't really natural on the prairie. So they plant these rows of trees to break the wind, to stop the wind from gaining too much strength and eroding the soil away on the farmland. So they're using trees or other vegetation, tall vegetation, to form windbreaks. A good way to stop erosion. And that's it. So be sure you take good notes. Remember, I will be checking notebooks before the end of the 9 weeks for a grade.